Good morning and afternoon, everyone. Welcome to today's webinar, Choosing the Right Database for Time Series Data. My name is Alicia and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter at MemSQL or live tweet us during the webinar using hashtag MemSQLwebinar. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. Let's begin today's presentation on choosing the right database for time series data. Achieving fast database performance for time series applications often comes with trade-offs in terms of performance, integration with existing tools, and usability. In today's webinar, we'll provide an overview of the database options for managing and analyzing time series data with special emphasis on how MemSQL can be used to manage this rapidly growing workload. We'll also leave time for some questions at the end to help you learn more about MemSQL. With that said, I'd like to introduce our speaker, Mike Boyarsky. Mike is Senior Director of Product Marketing at MemSQL. Mike has extensive experience in databases and analytic technologies, having worked at some of the leading database and BI tools in their space. Thank you for joining us today and welcome, Mike. You have the floor.
Awesome, thank you, Alicia, and thanks everyone for attending today. We've got a pretty exciting topic, very popular topic around time series data. Why is it gaining popularity? Some of the technologies that are out there to help you sort of manage this data type. We'll also spend some time explaining how MemSQL can be used for managing this, of course, but also giving trade-offs on what other options and alternatives are available out there in the market. And then we'll conclude with a customer example from a MemSQL customer that's using us for this particular workload. And then we always have time for Q&A at the end. I do always recommend that if you have questions as I'm talking, submitting those right away instead of waiting till the end, because sometimes we just don't get to all of the questions at the end. So we'll start with the basics, right, which is what is time series data. It's pretty straightforward, but also it has some nuances. Obviously it's a series of data points that are indexed in time order. Often these it's a sequence of data that's taken at successive points in time, and sometimes that time can be regular intervals or irregular intervals. It kind of depends on the application and use case. And there's a number of popular time series applications. These seem to be growing in terms of number, but some of these are sort of obvious around equipment and device monitoring. There's a lot of financial applications around pricing and trading applications that want to make sure that they're collecting each event with a timestamp to look at trends, etc. Manufacturing systems have always been looking at the equipment performance and yield over time. Oil and gas equipment, obviously lots of heavy capital intensive equipment, whether it's planes, trains, logistics applications. And then of course, a lot of DevOps monitoring tools around servers, configurations, application usage, etc. A lot of that data is collected using some sort of timestamp in nature. And the popularity of managing this data using databases has grown in terms of over time. This is a stat from DB-Engines, and you can see there that the time series database management system in terms of interest has risen quite dramatically over the last several months. And so that's one of the reasons that we wanted to spend some time talking about what the options are out there in terms of using database management systems for time series data, and what are some of the trade-offs, and then more in particular, how MemSQL can be uniquely suited to address this workload. So let's get into some of the database options out there. And it comes with some context, right? So the life cycle for managing time series data is a sequence. Usually it starts with an event that's created through an application. whether it's sensor-driven, whether it's application-driven, user-driven. In many cases, a lot of these events are queued in using a message queuing system like Kafka or other traditional sort of ESB solutions, or Spark Streaming and Flink. Anything that can take an event or a message and pass it and collect it and organize it and push into a collection store or a data store. In some cases, there are applications that will transform that event data, whether it's to normalize the data, whether it's to do things like data cleansing in real time. That is sort of one of those optional steps that depends on the application, and it can be driven by Python or Java or some stored procedure that helps ultimately basically organize that data before it lands into a data store. And then once it lands into a data store, there's a couple different approaches. One is an immediate response to the event data. And so this is where you can get into really interesting applications that do real-time scoring, which can look at sort of thresholds and determine an action. And so once a threshold is met, you can have a database alert or trigger occur. And so some action can take place based on the threshold that is met. And oftentimes that should be powered or enabled through an in-memory processing unit so that it's super fast. Millisecond response for a lot of time series data is often a requirement. And then, of course, as the data ages over time, then you can get into scenarios where you're doing more ad hoc queries and you're looking at spot checks of data. Maybe you're just doing aggregates on different types of scenarios of the data and the shapes of the data, probably being used by different parts of the organization or users. And maybe the real-time queries are being automated through machine-to-machine communication, whereas the ad hoc queries are being driven by a dashboarding tool like a Looker or Tableau, etc. And the ad hoc queries typically need to scan a lot of data. And so this is where the data being oriented in column store format with good compression and gives you really fast aggregate queries is ideally the architecture that you want for storing that type of data. Whereas the real-time data, sometimes it can be raw and just organized in a in-memory row store format so that you can get super fast response, that millisecond response when it matters most. And then over time, data can be moved into an archive mode for a variety of purposes, whether it's for data science, for looking at data mining applications and looking at new models to score, et cetera. So there's sort of a life cycle that occurs with a lot of time series data. So we're going to spend most of our time looking at the database solutions out there that help throughout this sequence. So here are some of the common requirements, and of course this isn't exhaustive. We've got a short amount of time to spend today. We could spend in any one of these columns 30 minutes or an hour just talking about the functionality. The point here is to give you a sense of the high-level categories of capabilities that you often are going to need for managing most time series applications. Starting on the left with transactional functionality, you need something that a database that can be storing immutable transactions. You don't want those transactions to be changed once they're committed. Changing data once it's committed to a database is usually, especially for time series based applications, can create just errors and sort of logic functions that are not correct. You typically are going to want to have a database that provides ACID compliant transactions. That gives you the assurance that those records are committed and complete and have been accurately represented in the database. And lastly, you also will want something that can give you very high throughput in terms of ingestion. So you want high speed throughput because many time series applications, the data is streaming into the environment very, very rapidly. Sometimes it's intermittent. There's bursts of data, and your database needs to be able to accommodate that ingest environment. You also need a very scalable database. So the fact that your workloads may change over time. It may be, again, very bursty over time, or just simply a very large deployment, and deploying on a distributed architecture makes life a lot easier versus going into sharding mode and coming up with sharding techniques and all of the overhead that comes with sharding your data. You really want the database to be built and designed around just a distributed architecture. Just makes life easier, and it's built for growth, essentially. You also want a database that can give you tiered storage. You want the choice to choose between super lightning fast response that's usually in-memory powered versus disk-based, which might be more columnar disk oriented, so that you have choice and flexibility to determine what's the best hardware architecture to address the response needs that you have for your application. Having both, I think, is the best choice versus getting forced into one over the other. And then lastly, you want an environment that can give you the great concurrency. We see applications that grow in popularity. Maybe you have different applications that are accessing the data, different types of users that want access to the data. And we see a lot of throttling that occurs with the database if it's being accessed by different apps or users, and the performance gets degraded, and you ultimately run into data mart and replication of data to other places. That just creates headaches. It creates more cost, more complexity, more management overhead. Ideally, you want a database that can keep all the data in one place during its life cycle, and then once that life cycle is deemed complete, then you can move that data to some other storage architecture, whether that's in something like Hadoop or some object store in the cloud. The operational capabilities usually are very important for time series applications because they're always on. 24/7 operations means that you need something that is highly available, highly secure, the ability to provide sort of auditing. So in the financial service applications, auditing is super important for a variety of compliance requirements. The ability to back up and recover elegantly and quickly without going offline, and also being able to deploy wherever you like. So a lot of companies today are trying to figure out ways to augment and or sort of protect against being locked into one particular cloud provider or deployment architecture. And so having flexibility from that perspective can give you more advantage down the road. And then lastly, analytic functions. We see a lot of customers that need the spectrum of performance around analytic queries, whether it's real time or whether it's just classic fast data warehouse style queries. And that means organizing your data in column store format, because most time series applications, they grow their data footprint quite rapidly, and so you need an intelligent way to keep that data footprint at a minimum. And using column store as a way to compress data, having that run on disk makes things less, more cost effective and gives you great performance. ANSI SQL really is central to providing proper analytics. Most applications, whether it's a BI tool, whether it's familiarity with an analyst, a data analyst, and the skills around running queries, a lot of organizations want and need ANSI SQL for that compatibility and skill matching. And then lastly, there are time series specific analytic queries that are useful, especially as the data sets grow in size. There are certain functions that maybe not elegant in a pure sort of ANSI SQL perspective. And so you might want to deliver sort of specialized SQL functions that deliver sort of packaged queries, if you will, for specific time series requirements. And so this sort of gives you a quick backdrop to what the ideal database sort of requirements and capabilities would be for a time series application. And so now what I'll do is I'll sort of summarize these into their respective categories and give a walkthrough as to the types of options that are out there. Legacy relational is what I'll consider your classic sort of, Oracle SQL Server, DB2, et cetera, those databases that were designed with single node architectures, very, very sound and relational capabilities, super strong in their operational capabilities. They've got great transactional performance from transactional capability. The performance and scalability is actually where things fall down. Most of these systems cannot keep up with the throughput, so that comes down to stream ingestion requirements and also multi-node architectures. It becomes very difficult to shard and or scale some of these legacy relational environments. However, they are very strong at their operational capabilities. They have a number of years behind them in terms of plugging into very highly stringent, HA requirements, security requirements, all the operational tooling that's part of that. And their analytics support is quite strong in that they are relational SQL. However, in many cases, they may not have all of the capabilities of SQL time series functions out of the box. And so not all of these legacy tools provide sort of specific time series analytics built in. There's a number of NoSQL options. I think this is probably one of the more popular choices that we see in the market around using sort of an open source based NoSQL store for time series data. Very strong in their transactional support, although some of them do have eventual consistency models, so you can get into more controlling the consistency of the transaction and into the logic of the application versus into the database itself. So there are some scenarios where some of these NoSQL stores can get you into essentially a little bit of trouble around managing those transactions and ensuring that you're getting exactly one semantics, exactly one event per transaction, and ensuring immutable support for those. Their scalability for NoSQL is very strong. Most of these are distributed in nature. They're very good at throughput, ingestion, etc. So they're very strong from that perspective. And I think that's usually one of the main reasons folks love these styles of databases, is that they get this great scalable performance. However, their maturity are such that some of their operational capabilities are just not there, that maybe, because they're newer, they don't have all the frameworks, they may not have all the security, they may not have all the backup and recovery functions that you might want. And so there are some operational trade-offs around some of these newer, maybe less mature NoSQL stores. And then lastly, the analytics, while some of them have purpose-built analytics for time series, many of them are using SQL-like capabilities. So you're going to run into trade-offs around BI tool compatibility, just running your standard ANSI SQL queries for other parts of the business. So you're really kind of making a bet that this time series application will be only used for specific time series analytics and not other types of analytic scenarios, ad hoc queries that are very common with a lot of data. And so you are now forced to make a decision around replicating the data out of this NoSQL store to something that's traditional in nature or relational SQL in nature. And so that's a trade-off that you are going to be making with some of these NoSQL stores. And then we have NewSQL, which is kind of a best of both in that it gives you great transactional guarantees. It's got the ACID compliant transaction support. It's immutable support. You get great scalability. You're going to get into scenarios where these are multi-node or distributed architectures, give you very high throughput streaming ingestion. They've got lock-free architectures. They're very, very strong from an operational perspective because they have a lot of the attributes of your legacy relational systems in terms of their availability and security. And then the analytics is quite good because you're getting ANSI relational SQL. You may not get all of the out-of-the-box time series queries, but many of these, and we'll get into MemSQL in particular, there are ways to address that quite easily. And so ultimately what you're getting is sort of a high performance application or platform that also plugs and works with a lot of your existing tools and skills around working with relational SQL data. So we're going to spend now the next part of the presentation getting into more of the nuts and bolts of MemSQL and how it can provide great performance and capabilities for managing time series data. So first, for those that are new to MemSQL, I want to give you just a little bit of context of who we are, what kind of companies we work with. Well, we're all about performance, delivering speed and scale for your critical data infrastructure. Our belief is that data analytics and data management shouldn't require specialized data stores. You can get great performance across a spectrum of analytic requirements using a database that is built for both database and data warehouse workloads. And so we'll get into how that's achieved in a moment. You can see some of our customers were used by a number of data-driven organizations that have lots of data that is coming in real time, and they need to make operational decisions in the moment. And so some of this data is time series based, some of it is burst based, if you will, and that it's maybe more geospatial in nature or just classic operational data. And so the point of today's discussion is to get into a little bit about what makes MemSQL tick, what makes it different from some of the other solutions out there. It has a lot to do with our scale out relational SQL capabilities. So we are one of the few scale out SQL databases that gives you great performance across a spectrum of ingestion. So we have a lock-free ingest architecture. We also have extreme performance at the query processing layer. And also because we are distributed, you get great concurrency. And so this gives you that ultimate flexibility in terms of delivering performance across a variety of bottlenecks that typically occur with other legacy solutions. We are agnostic in terms of where you can deploy us. You can be deployed in the cloud, on-prem, in a public cloud, it doesn't matter. And often we see dramatic performance over traditional legacy providers with a much more cost-effective approach or model. In terms of how we work with a number of other existing tools, we see a lot of customers using Kafka, streaming data into MemSQL. We'll get into a little bit about how we manage that data once it lands into MemSQL. We can, of course, work with off-the-shelf ETL tools or Spark. We see a lot of customers using us next to an existing operational database, whether it's Oracle or SQL Server or data warehouse for that matter. We see also a lot of customers using us in conjunction with Hadoop architectures, so giving sort of a speed layer, if you will, on top of a Hadoop data store to give you great relational SQL analytics. And then the beauty of MemSQL is that we plug in really seamlessly with existing tools that are usually already in place in your organization, whether that's a Tableau dashboard or Looker environment or MicroStrategy, or just your regular SQL relational endpoint for data analysts. And so in terms of getting into a little bit more the depth of what we offer, we are scalable SQL. That means full ACID compliant capabilities. We have a full lock-free architecture. That means we can stream ingest data in parallel so that we can get dramatic performance. And so we have customers that are ingesting up to, in some cases, millions of events per second. I think we've got a customer that's reached about 10 million upserts per second. That is an upsert, so that's a particular clarification. Full ANSI SQL. We support a variety of data types, whether it's document or JSON. Geospatial is built into the platform. We are, of course, shared nothing architecture, and so the scale out architecture is powered by commodity hardware. So there's no special hardware appliance requirement needed here. We run on your basic off-the-shelf hardware. It does quite well, whether that's in the cloud or on-prem. We also take advantage of in-memory. Of course, that's built into our name, but we're not just an in-memory store. We also believe in disk, whether that's solid state or spinning, and that's all stored in column store format. And so I'm going to get into a little bit more about the column store versus row store in a moment, because that's really where the difference is in terms of our architecture. And then again, I mentioned earlier about our deployment architecture and the fact that we're agnostic. That gives you flexibility and choice ultimately. So this is kind of where it comes down to in terms of the architecture of the product and why we sort of make a difference for most organizations. And it's the choice between streaming data in. So most time series applications, the events are coming in continuously, and you want to be able to collect those and respond or analyze those immediately. And so because we have the ability to stream data into our in-memory row store format, you get very, very fast performance, millisecond response, but you can also stream data into our column store that's on disk. So this is essentially two engines in one, right? A row store engine that's very transactional in nature, all in memory, super fast, but you can also stream data directly into our disk-based architecture, which is a column store format. Not very many databases, in fact, no databases choose this style of architecture. You either pick one path or the other. You either put everything in memory and then you put it to disk, or you put everything on disk and then you roll it into memory. We give you the choice, and that's dependent on your application, depends on your needs, your response requirements, and we have a lot of customers that do a combination of both, and that's really what makes the difference for the performance. And so when you get into some of the more nitty-gritty details about our row store tables, these are great for fine-grained aggregations, very good for updates and seeks, deletes, etc. At the gigabyte to terabytes of data. There is no compression, so you do get the sort of, there is a sort of aging process that you might want to do with your data as it lands in memory. You might want to move it to the column store format over time. The great thing about our column store tables is it acts like a data warehouse. So it's got all of the fast queries and scans, big data aggregations at the terabyte or petabyte scale. You get the great compression. And so it's the combination of these two engines working together that gives you millisecond response time, but you're not sacrificing familiar SQL. And so I think that's one of the things that we're trying to educate folks is that you go down the NoSQL path because you think you're getting scale and performance, you're getting ingestion capabilities, but then you're losing out on providing a familiar interface for other parts of the business or other applications. And so now you're having to make different kinds of decisions around what to do with that data store and how far can it go in terms of providing value to your business. And so, when we get into a little bit more about how our column store versus row store work together, there are different sort of attributes around our indexing architectures and the way we work with the different types of inserts and updates. We love the sort of batch insert or updates as well as the stream insert, so it doesn't really matter in terms of how the data comes in. And also, it doesn't really matter if you want to ingest directly to our in-memory engine or into our column store engine or both. You get that flexibility. And then in terms of the robustness of queries and analytics, some folks that are in the time series only world will say, well, wait a minute, how do you guys provide very fast query performance for these specialized time series functions? Well, first of all, let's just point out that we're extremely fast. We've got record-breaking performance because we have fast query vectorization and compilation. So we actually compile our queries down to machine code. So those repeat queries that you're commonly going to be doing for an operational application, these are queries that are the same queries running over and over. Those are compiled to machine code, and that makes them lightning fast. So that's one attribute we have. Then we also have your full ANSI SQL query requirements. So the inner and outer joins, scalar and window functions, subqueries, views, etc. Those are all built in. That's just part of the application. There's no special sort of hand-wringing required to get those to work. And then lastly, if you do need specialized query functions for down sampling or smoothing or bucketing or different types of custom grouping or interpolation, which is very commonly used for time series applications, we have a very robust extensibility layer that allows you to build those functions very easily. In fact, we'll be sort of showcasing some of those as examples to give you an idea of how to build these applications, and that's from the real world experience with our customers that are using us for managing time series data and specifically doing time series analytics. So I'll lastly conclude with a quick customer example, which is Fanatics. They are doing, basically they're an e-commerce site specializing in sports merchandise. And so they're doing about $2 million in revenue, very popular in North America. They manage about 200 professional and collegiate teams in terms of their gear and merchandise, and they had this architecture here for managing essentially the supply chain for events that are coming into their application, managing everything from the buyer experience in terms of inventory management, in terms of the customer service sort of experience and helping respond to questions. So this is the full application for what powers their e-commerce application. And in terms of the time series data, they're collecting a ton of metrics on user behavior, activity, etc. And it's all coming in real time. And so that data is getting analyzed, it's getting collected and analyzed immediately. And so what they were using prior to MemSQL was a combination of these tools, whether it was Redis and Flink and Spark and Elastic. They're using primarily Elastic for their time series metrics and measurement and analysis. And ultimately what they ran into was just a pure overhead on the complexity of the architecture. Too many tools, a lot of unexpected outages. They were troubleshooting where the bottlenecks were. They had all these moving parts. And so ultimately they found themselves having a lot of trouble keeping the environment maintained and running at a high performant level. And so they moved to MemSQL. And also just to point out, like, this is where specifically the time series data was being managed largely between their Redis and Elastic environment. They moved to MemSQL for, first of all, to get just a handle on all of these disparate tools. They've just had a lot of complexity, and they simplified by reducing the number of data stores and duplicate data that they had in their application. But then they got great time series management and analytics, but they also got follow-on benefits, which was being able to do other styles of analytics around that data and the type of data, because it's a relational SQL database. And so they kind of got the best of both worlds around managing their very specific time series oriented data, but then they also got all of the benefits of connecting Looker and MicroStrategy and doing more ad hoc analytics and real-time dashboards for other types of data that was in the application, as well as looking at that time series data in different ways. And it had a lot to do with the fact that they were working with a relational SQL database that acted and behaved like a lot of their other databases that they worked with. And it wasn't a specialized environment that was only doing one thing, which was time series specialized analytics. So just to wrap up, just to kind of give you a sense of what MemSQL can do for time series in particular. It's all about being a scalable ANSI SQL database that can give you great, robust transactional support, leveraging lock-free ingestion, so you get that streaming ingest capability, and then you get great query performance that looks and is very familiar to your organization from a tool interoperability perspective, as well as a skill set. And then if you get into the more details around the different types of data, whether it's geospatial in nature or JSON, we've got all of that covered, built into the product, and you've got all the operational capabilities that you would expect and need from a high-performing operational system. And so with that, I'm going to now kind of transition into at least promoting the fact that we do have a free tier option, which means you can use our product with no time limits. You can deploy to production. It's full-featured, and you can use it up to 128 gigabytes of RAM. And that's unlimited disk, so you can put as many terabytes or petabytes that you want. And if you want to get support on that, you just get help from our forums. And I will now hand it off to Alicia, and I think she's going to ask a few questions.
Thanks for your presentation, Mike. Let's now answer a few questions from the audience. As a reminder, you may submit questions to the Q&A function located in the lower right side of your console, or tweet us using hashtag MemSQLwebinar. It looks like some questions have come in. Let's start with this one. Does MemSQL support JSON data types?
Yeah, absolutely. Yeah, JSON is a native data type that we have a lot of customers actually working with. So we see some really clever ways to use JSON within our column and row store formats to do things like computed columns, I highly recommend if you go to our docs page and docs.memsql.com, you can take a look at all of the sort of ways to use JSON data types. But the summary there is that a lot of customers use it. They get great performance. I think a lot of folks feel like only Mongo can manage JSON properly, and that's just really not the case. If you take a look at how we achieve that through great performance, you can look at our docs page for more detail there.
Great. Can you talk about how MemSQL is distributed with no shared architecture?
Yeah, so I didn't show a picture of our architecture. I should have, but it's a distributed architecture in that we have this notion of a aggregator and a leaf node. So think about aggregators as the sort of control point for where they know where the data is laid out, and they're essentially powering the queries and orchestrating the queries. The leaf nodes are the nodes that are storing the data. So this is the place where the actual data lives, and it's fully distributed. So that data is sort of automatically sharded without any of the complexity of doing it yourself. And so the aggregators and the leaves work in concert to essentially determine where best to run the query. Ultimately, I think the best place to get a visual cue of how our architecture works is, again, going back to our documentation page, docs.memsql.com. How MemSQL works, it gives you a very simplified way and architecture layout on how our shared nothing architecture works. Yeah, unfortunately, I don't have a visual built into my slides, so it's usually the best way to showcase that.
How does MemSQL perform against Redis?
Yeah, we see a lot of users looking at Redis for key value sort of workloads. It does a great job of optimizing on memory. So it's got very high throughput performance, great sort of lookup query performance. But where things sort of get different between us and Redis is that while we also take advantage of memory, we do persist data on disk, and then we put data into a column store format, so you can do other more interesting analytics. So you're sort of limited on the amount of analytics that you can run on Redis. It's really not meant for your exploratory ad hoc queries, so you have to then move data out of Redis to something else. And that's the whole point that we're trying to avoid is the decision around moving data out of your data store to something else. Now you're duplicating data, you're creating complexity, cost, whether it's people, management, etc. We think with MemSQL, you get the same performance as Redis. It's full in memory as well as disk. It's distributed, so you get parallel ingestion. That's the lock-free architecture, just like they have. But now you get great queries and analytics without having to move your data to a specialized data warehouse.
How is MemSQL compared to Snowflake?
Yeah. So MemSQL has data warehouse capabilities built in, just like Snowflake is a one workload environment. It's very good at data warehousing, so very good at sort of read-oriented queries. Will differ when it comes to ingestion rates. So Snowflake was never architected to manage real-time ingestion. I know they have various ways and techniques to try and make that work, but it's really not the same sort of approach. Our database was designed for streaming ingestion, and so you're going to get that ingest throughput at a much higher level, much more scalable level than Snowflake. Snowflake's going to give you, just like MemSQL, great aggregate queries and ad hoc queries. You also have the limitation that Snowflake only runs on Azure and Amazon, and we run on those as well as anywhere else. So if you want to run on-prem or in some other cloud like Google, you've got that choice with MemSQL. So it really comes down to how important ingestion and deployment architecture, and then just overall cost. We've seen some customers running into some some cost challenges when you're talking about running Snowflake continuously in an operational mode where you're never turning it off. The bill tends to get increasingly higher with that environment.
Great. It looks like we have a couple more questions coming in. How well do you deal with time series data that may be ingested in varying order? We may get old data from IoT devices that don't have a network connection.
Yeah, that's a great question, and certainly, pretty common for those more sensor-based systems. We have a couple customers that are managing, appliances, machines, smart meters. And this happens quite frequently, and so there's a number of different approaches to managing this. For us, as in terms of a built-in capability, we have, in terms of the ingest capabilities, we're going to offer the classic, ACID transaction support. So we're going to ensure all of those events, whenever they take place, will be committed to the database. And then the harder part is figuring out how to normalize the queries to make up for the gaps in time. And so we are actually going to be showcasing exactly how to perform that query using our extensibility layer. It's a pretty common sort of need. And so we'll show you through code how you can perform the queries that would address, again, the non-irregular or the irregular event ingestion that's common with a lot of sensor-based systems.
Does MemSQL fully support SQL queries?
Of course, yeah. We're a relational SQL database, so we're ANSI SQL. We believe in that to a core. So that's what we're all about. A lot of good questions here that keep coming in.
Can you say using MemSQL we can skip using data lakes?
Sure. Yeah, we have actually a customer in the utility space that has stopped using their data lake architecture and using MemSQL, and it had a lot to do with performance and then also cost. So they were able to put everything on disk, compress the data, so they saved a ton there. But more importantly, they were not dealing with all that headache of getting data out of Hadoop in a responsive way. And so, yes, the short answer would be yes, we can serve that. But we also work with HDFS well. We have an HDFS connector. So if you want to still push everything into HDFS and then pull it into MemSQL for spot queries, you can do that as well.
What is the license model? Is there free tier? If yes, are capability or functionality limited?
Yeah, so we do have, we're a commercial product, right? So, but we do have a free version of our product that is ungated. So that means there's no limits. There's no functional gaps, full security, full HA, full performance. The only limit, I guess, is that you can use up to 128 gigabytes of memory. So that means your cluster can only have 128 gigs of memory, but it's unlimited disk. So just think about, those queries that need to have millisecond response, you might want those to sit in memory, but all of your other queries can sit in the column store and you can get great performance. So our free tier is very capable. And in fact, we have some customers that use our free tier for a number of other spot applications.
Does MemSQL also perform integrity constraints while stream ingesting?
Yeah, of course. Yeah, we have, I mentioned earlier, a full ACID compliant database. So it really comes down to sort of how fast and what your performance threshold is. So there is a, sort of the commit transaction event has to be sort of verified on disk. And so there are some scenarios where maybe that performance, sort of requirement is such that you can sort of forego some of the sort of handshakes or the sync replication process that's a part of that ACID process. But stay tuned because we're working on some new capabilities that gets us to super high performance with guaranteed transaction support that we think is going to be, sort of game changing for the platform. But again, we are an asset compliant database, so we have all the classic guarantees that you would expect of a SQL database.
Do you need an administrator to manage the database, as we were seeing auto DBs on the rise?
Yeah, we still, there's still a full sort of studio management utility framework that we offer with the product, so that comes, of course, for free. But having said that, you're sort of leading into sort of autonomous database management. Yes, we have some capabilities that we've been introducing over the last several releases that do a lot of the workload management in a sort of automated way. I think a lot of our sort of customers that have been running, for example, an Oracle environment, they can essentially cut the management overhead in terms of resources, people, time dramatically. And sometimes it's down to less than one half of a person in terms of time and effort. So overall, management is still needed to set up the database, configure it, and then once it's running, we don't really see some of the overhead that's common for a lot of traditional database systems. So so in general, I think the tone for us is we're going to continue to automate those functions for you so that you don't have to constantly manage and monitor. And we're going to continue to make that better.
Great. It looks like we may have time for one more. What are some of your largest deployments in terms of data ingest, number of sensors, and total size of database?
Yeah, so we commonly get asked how big is the biggest customer, et cetera. And, ultimately it comes down to how many events are coming into the database and what's the largest or high watermark for that. And I mentioned earlier 10 million upserts per second is one example application. That's I think it's, I don't know how many nodes, I think it's close to 100 node system. So there's really no limit in terms of our high watermarks. So we don't have, we call ourselves the no limit database for a reason, because there's no physical or technical limit. So you can always add more nodes to get more throughput. And then in terms of, and so how many sensors is that? Yeah, we have, as I mentioned earlier, some companies that are doing utility grid management. So there's a number of smart meters. We're talking tens of thousands. We've got equipment monitoring solutions where the events are coming in millions of times a second. And then when we get to just total size of database, we are close to petabyte scale. I mean, there theoretically is no limit in terms of how much data can be managed. I think we're at some of our customers are getting close to the petabyte scale. We have, Pandora's got an awesome blog on our website around how they're analyzing, I think it's a 300 million row table, and doing that with sub-second, performance. So lots of cool performance at very big, large scale. And so, I guess that's some anecdotes there.
Thank you, Mike. Thank you, everyone, for all of the questions. Unfortunately, that's all the time we have for today. For those of you with questions we did not get a chance to address, we will follow up with you directly. I want to thank Mike and each of you for attending today. Just a reminder, we will be sending you a follow-up email with a link to today's recording and the slides. If you have any questions in the future, you can send an email to team@memsql.com. We invite you to learn more about MemSQL at memsql.com or give us a try for free at memsql.com/product. Again, thank you for participating and have a great remainder of the day.